Architecture of Kubernetes. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Understanding the architecture of Kubernetes is essential for effectively deploying and managing your applications on this platform. In this part of the course, we will dive into the architecture of Kubernetes and understand how its various components work together to provide seamless container orchestration. Control plane architecture. The control plane is responsible for managing and controlling the Kubernetes cluster. It consists of several components. API server. The API server acts as the primary interface for all operations within the Kubernetes cluster. It handles requests from various clients, including the command line interface, CLI, and the web-based dashboard. The API server validates and processes these requests before storing them in the etcd data store. etcd. etcd is a highly available distributed key-value store used to store the cluster's configuration data. It stores information about all the resources and their desired states, serving as the single source of truth for the cluster. Scheduler. The scheduler is responsible for assigning workloads to specific nodes in the cluster based on resource availability, constraints, and policies. It ensures efficient resource utilization and high availability by distributing workloads evenly across the cluster. Controller manager. The controller manager is a collection of controllers that continuously monitor the state of the cluster and take corrective actions to maintain the desired state. These controllers include the node controller, replication controller, endpoint controller, and service account and token controller. The node architecture consists of the worker nodes in the Kubernetes cluster. Each node runs a set of services and containers that make up the running application. The key components of the node architecture are kubelet. The kubelet is the primary agent responsible for managing containers on a node. It communicates with the control plane to retrieve the desired state of pods and ensures that the containers are running as expected. Container runtime. The container runtime is responsible for running and managing containers on a node. Kubernetes supports multiple container runtimes such as Docker, Containered, and Cryo. Kube proxy. The Kube proxy is responsible for network proxy and load balancing operations on each node. It enables communication between pods and services by managing network rules and forwarding requests. Pod. A pod is the smallest deployable unit in Kubernetes and represents a logical grouping of one or more containers. All containers within a pod share the same IP address, network namespace, and storage volumes. Pods are scheduled onto nodes by the scheduler. The networking architecture in Kubernetes is pluggable, allowing you to choose and configure different network providers. The key components of the networking architecture are pod network. The pod network is responsible for providing network connectivity between pods running on different nodes. It ensures that pods can communicate with each other seamlessly. Service. A service is an abstraction that represents a set of pods and provides a stable network endpoint for accessing them. Services enable load balancing and service discovery within the cluster. Ingress. The ingress resource defines a set of rules for routing external traffic to services within the cluster. It acts as an entry point to the cluster and provides features like secure sockets layer termination and path-based routing. Kubernetes provides a flexible and extensible storage architecture to manage persistent data within the cluster. Some of the key storage components are persistent volume, PV. A persistent volume is a piece of storage allocated to the cluster that persists beyond the life cycle of any individual pod. It can be dynamically provisioned or pre-allocated. Persistent volume claim, PVC. A persistent volume claim is a request for storage made by a pod. It allows the pod to consume storage from a persistent volume. The PVC binds to a PV based on its requirements, such as size and access mode. Storage classes. Storage classes are used to define different types of storage offerings in the cluster. They provide a way to dynamically provision storage based on the requested class. For example, a storage class can specify whether the storage should be SSD or HDD. This part of the course provided an in-depth understanding of the architecture of Kubernetes, covering the control plane, worker nodes, networking, and storage components. Understanding the intricacies of Kubernetes architecture is important towards leveraging its capabilities for orchestrating your containerized applications.